Hello, Algebra 1. This is our lesson on inverse operations. So as you can see, I've already copied down the main definition from slide number 5. So why do we do inverse operations? And it's to maintain the property of equality. It's super important to know, right? We'll be asking you guys this on Friday during live instruction, and whoever can answer that will be given extra credit, okay? So to maintain the property of equality, that just basically means whatever is done to one side must be done to the other. Now, here are the main 6 operations that occur. Again, you'll find this on slide number 5. So if you add, the opposite is subtraction. And if you subtract, the opposite is addition, okay? That's why there's an arrow pointing both ways, because you can go back and forth between these two. Multiplication is the inverse of division, the same as division is the inverse of multiplication. And if you have something squared, the inverse is square root. And if you have something square rooted, the inverse is squaring it, okay? Now we're going to look at 4 examples that you'll find on slides 6, 7, 8, and 9. Please make sure that you're copying down everything that is done in this video so that you have a sample in your notes before you do your IXL work. So the first problem says solve for A in terms of B and C. The most important thing is to understand how to read the instructions. So the most important thing here, it says to solve for A. Whenever you see in terms of, you ignore everything after. And again, that's going to be a question that we ask in Friday's class. Okay? You just ignore everything after. It's just saying in terms of means acknowledging that the other variables are there. Okay? So I see that there's no numbers, but that's still okay. I can still solve for a letter. So I'm looking at A. I want to solve for A. What's happening to A? A is being added to B. So I'm going to say A is added to B. That's my plus sign, my addition sign, okay? Now, what is the inverse of that? The inverse of addition, as we saw up top, right? You always want to refer to this. The inverse of addition is subtraction. So just to undo it, right, I'm just going to subtract B on both sides. So I'm going to say subtract B to both sides. Okay, because that was my next step. Now, these will cancel because they're inverses, they're opposites, right? C and B are not like terms, so they won't cancel out. They'll just go right next to each other. So my answer for here is going to be A equals C minus B. And this is how I leave my final answer. When they ask you to solve for A, that just means they want you to get A alone. And I want you guys to keep that in mind as we're moving through our other model problems, okay? So model problem number 2 says solve for B in terms of A and C, okay? I have A, B, and C. What do I want to solve for? I want to solve for B. And in terms of all of this, you can just ignore it, okay? That's unnecessary information. So again, I'm looking at it. A, B equals C. Okay, well, in order for 2 letters to be stuck together like this, they're held together by multiplication. So I'm going to say A is multiplying to B, okay? And what is the opposite of multiplication? Well, I know that the inverse or the opposite of multiplication is division. And I can look at division as a fraction, right? So in order to get A away from B, I have to divide A to both sides. Okay, so I'm just going to go right ahead, make that little fraction symbol to both sides. Now, since these are inverses, they cancel, okay? And I'm left with B. So since C and A are not like terms, I leave it as is. So it's going to be B equals C over A. And that right there is my final answer because I solved for B as stated in the instructions. I got B alone, okay? Model problem number 3, solve for C in terms of A and B. Again, as soon as we see that in terms of, we cross everything out after. Don't worry about it. We're solving for C. Now, this is a little bit interesting, right? So I have A, B, and C. Now, what's happening here to C? So B is being divided by C, okay? And the opposite of division, as we've noted before, is multiplication. So I know that I have to multiply C to both sides, okay? But how does that look? So you can just do something like this. I'm going to use a different color just so that it stands out. I'm just going to go like this. Multiply by C to both sides. Okay? So since these are inverses, they cancel. Okay? And I'm left with C times A equals B, or CA equals B. Now, the reason why the reason why I multiplied is because I cannot solve for a letter if it is at the bottom. Whenever you see a fraction, the very first thing you want to do is get rid of that denominator. Now, I'm not done because I did not solve for C. I see now that C is multiplying with A. So I'm going to write that here. C is multiplying with A. And since I want to get C alone, I want to divide A to both sides. Okay? So again, making that fraction symbol. And then those A's cancel out. And I'm left with C equals B over A. And that right there is my final answer. Okay? Now, model problem number 4 is going to look a lot like your IXL. And we just wanted to make sure that you got an example in your notes so that you weren't left confused with your IXL work. Okay? So this says here to solve for B in terms of A and H. Solve for B, so that means we're going to ignore everything else, right? We want to get B alone. Let's look at what's happening. So I have a fraction B and H. So I know that 1/2 is being multiplied with B and being multiplied with H. That's the only way that the three of them can be stuck together like that, okay? Now, as I mentioned earlier, whenever you see a fraction, the first thing you want to do is multiply by the denominator to get rid of, okay? So since this is 1 divided by 2, the first thing I'm going to do is multiply 2 to both sides. And again, just so that it stands out, I'm going to go ahead and do that with my pencil. Multiply by 2, multiply by 2. Okay? Now, this is going to cancel with this here. Remember, the inverse of division is multiplication, so that's why they canceled out. Okay? So 2 times A is going to give me 2A. Okay? So 2A equals, now what's left? Just B and H. Okay? And I want to solve for B, which means I want to get B alone. So I don't have to worry about this side right now. But what's happening at the moment? B is still multiplying with H. Okay? As you can see in your steps, you have 1 divided by 2 and you multiplied by 2. So these kind of cancel each other out, but you still have B times H. Now, if I want to get B alone, I got to get this H out the way. So the inverse of multiplying is dividing. So I'm going to divide H to both sides. Okay? Divide by H, divide by H. Those cancel. Okay? And finally, I'm left with 2A over H equals B. Or, since the variable that we solve for has to be in the front, B equals 2A over H. Okay? And that, ladies and gentlemen, is my final answer. So this is going to look like your IXL, and so are the first 4 model problems. So please just make sure that you copy all of these into your notebook before doing your IXL. And if you have any questions, please come to office hours.